Hello, everybody. Welcome to the APS webinars. We're happy to continue our first student-led undergraduate seminar series, Pulse, with a panel on understanding independent research in physics.
Hello, I'm Keshav Samrat Modi, APS student ambassador and graduate student from ACSR at CSIR Chandigarh, India. And I will be your host for today's broadcast. I am joined by Ritik Balian, an undergraduate student at Delhi University, who will be moderating the question and answer portion of the webinar. And Stephanie Harvey, APS Industry Program Manager, who is providing technical support. Thank you all so much for joining us. APS webinars are brought to you as a service of American Physics Society, connected you with the expertise of individual who can offer insight into physics career, educational programs, and professional development for students, working physicists, and educator. Slide 2. So this is the second seminar in the newly launched series, Physics Undergraduate Learning and Sharing Experiences, that is Pulse. Our next broadcast will be on the lifetime of a research project and will take place in November. Please join us for these future broadcasts, which will take place over the next several months, and didn't forget to sign up for the APS webinar mailing list while using the link shown. Slide 3, please. This webinar series is organized and sponsored by the APS Student Ambassador. The Student Ambassador program allows students to represent APS at their local institutes to promote APS membership and resource while fostering a community of physics students locally and globally. You can visit the website on the screen to learn more about the program or apply. Next slide, please. APS membership is your connection to the wider physics community through news, research, and online directory, events, and more. APS offer distinct meetings, newsletter, and online collaboration spaces to help you zero in on the professional working in your field of study. You can advance your career with the access to the APS board, job board, webinars, and more resource for physicists. Next slide, please. I also like to highlight some of APS other resources to help students in their career, such as new physics job board, where you can explore job opportunities worldwide across different sectors. Before formally introducing our speaker, previous slide, please. Before introducing our speaker, I would like to go over some housekeeping item. Today's presentation features speakers from multiple research fields in physics with diverse career trajectories in industry and academia. They will be providing information about their backgrounds, exploration of different science fields, and how they impact with undergraduate in their lab. After the speakers finish the presentation, the remainder of program will belong to you for our question and answer session. Because of the number of people attending this webinar, we are only accepting text questions. So if you would like to ask a question, please type it into a question and answer panel located on the right side of your screen. Please indicate which panelist your question is for if you would like to hear from a specific speaker. You may submit question through the question and answer panel at any time during the webinar, and we will answer all of your queries at the end. We will do our best to cover all the questions that you submit, but we want to apologize if we are unable to cover everything. Finally, a link to the recording of today's presentation will be emailed to you after today's event and will be made available on the webinar homepage. Please allow 2-3 days for video upload. We encourage you to complete the survey upon exiting so that APS webinar can improve its ability to provide you with these valuable services. And so with that, let's get started. Next slide, please. So our first speaker, Dr. Anupma Thakur. She is currently working as postdoctoral researcher associate funded by the National Science Foundation, NSF, and the Department of Energy, DOE, at Purdue School of Engineering and Technology at Indiana University, Purdue University, Indianapolis, USA. She is also an early career researcher fellow at the Indian Institute of Technology, Gandhinagar, Gujarat, India. She completed a PhD as a DST-inspired research fellow at ACSIR, CSIR-CSIO, National Research and Development Laboratory, Chandigarh, India. In August 2021, she earned a gold medal in Masters of Technology in Nanoscience and Nanotechnology from Punjab University, Chandigarh, India in 2016. She also earned a gold medal in Bachelor of Technology in Electronics and Communication Engineering from Akal College of Engineering and Technology, Eternal University, Baru Sahib, India in 2014. She is a well-established young nanotechnologist in the field of advanced nanomaterial and material science for various applications, including materials for clean hydrogen, energy generation, carbon capture and utilization, chemical sensors, photo and electrocatalysts, extreme environments, and actuators. She has published more than 45 international high-impact publications, 5 patents are filed, while 14 books, chapters, and more than 25 conference papers, and delivers more than 70 oral talks. She has attended more than nearly 1,000 citations to her published research contribution. Next speaker is Dr. Brianna Mount. She was born and raised in Idaho and earned BS degree in physics and mathematics from University of Idaho. She received her PhD in physics from Florida State University. She is currently an associate professor of physics at Black Hill State University, and her research center on undergraduate physics at Sanford Underground Research Facility. Dr. Mount is the lab director of the BHSU Underground Campus, which is clean room facility on the 4850 level of SURF, and is also a member of Lux Zeppelin dark matter detection collaboration. Closely tied to her underground research, Dr. Mount is the director of several outreach activities. She is the project director of the BHSU Underground Science Research Experience for Undergraduate Program, REU. She has previously served as chair of the NSF REU Physics Leadership Group, NPRLG, and the APS Conference for Undergraduate Women in Physics, CUWIP. Next slide, please. Our third speaker, born and raised and educated in Southern California, Jesus received his bachelor degree in applied physics from California University of San Marcos. His undergraduate research was in condensed matter with a focus on classifying the magnetic property of rare earth orthoferrite ceramic. An early research experience at the Princeton Plasma Physics Laboratory convinced him to study plasma physics in undergraduate school. He has now studied the wave particle interaction that govern the dynamic plasma phenomena found in Earth magnetosphere. With this, now I am handing over the broadcast to Ritik to continue the our session. Ritik.
Yeah. Hello, everyone. Namaste. So now it's the time. Okay. Yeah, now it's the time to have some useful insights from our speakers, which will help us in attaining more clarity before starting or while doing independent research. Now, our whole conversation would be followed up by some questions from which our speakers would like to, share their experience with us. So our first question is the basic thing that we really want to understand, that from our speaker's experience, that when did they start their first independent research project. So Dr. Anupma, I think it would be great if you start with this.
Sure. So firstly, greetings everyone, and thank you for the kind invitation and opportunity to share my insights along with other panel members, Dr. Mount and Jesus. So that's great meeting everyone. So starting first, as an early career researcher, for me, my research focused on more independent research project started during my doctoral study. So when I was just starting my research thesis, I was granted a DST Inspire project, which cultivated to my more significant independent role in executing the project, starting from defining my research goals, which was more focused towards green hydrogen production. And basically the majority, the USP of the project was to design more photoactive materials for the significant hydrogen production. So that was my first experience, and the joy of learning throughout, exploring and reaching the research goals was exciting for me. And it cultivated through as we were progressing with the help of my advisors who guided me through. So yeah, that was my first independent research project, and it had many failures. But later, with more challenges in research and executing solutions, we were finally able to reach to the completion of the project. So yeah, the experience was so far learning, and it was enjoying as well. Thank you.
Yeah, it looks interesting. So Dr. Brianna, we would like to hear from you as well.
Good morning or good afternoon or good evening, depending on where you are. Thank you again for the invitation. My first experience with research was as an undergraduate. I don't know if you could necessarily say it's independent research, although I think aspects of it was definitely independent. I got an internship during the summer for 2 summers actually at Pacific Northwest National Lab in Washington State. And my first and I got to play with lasers for a summer and optics and kind of play around with that. And that was my first research experience. And I think research as an undergrad, since I'm speaking to a bunch of undergrads, I think is so important to decide what you want to do, if you even like research or physics or not. For me personally, classes weren't necessarily my favorite right off the bat. I grew to like them a bit more, but they can often be hard and challenging. And I think research, getting your hands dirty in a lab, kind of gets you through some of those tougher parts in your academic career.
Yeah, that's great. And we would hear more from you during the conversation. Jesus, it would be great if you can share your experience.
Sure. Hello, everyone. Thank you for having me. And my first research experience also came in while I was an undergrad. It came at the start of my third year after maybe the semester before networking and just getting the message that I had to apply to internships. I didn't necessarily know what I was applying for, but it ended up being a semester-long internship at Department of Energy National Lab. And that was the first time I was introduced to the research aspect of physics. And so it was about 16 weeks of getting to know my project and figuring out how to achieve the necessary goals. The independent part of it was really, me becoming the expert at the end of the project to a certain extent. And I think it totally changed my outlook, because as soon as I came back to my home institution, I went looking for a local advisor and a project to take on. And things just continued ever since.
Yeah. I think choosing an advisor or having an advisor is very important, and before early in the career. So yeah, now moving ahead, we would like to move ahead next in our conversation. And now we want to know from you guys, what is independent about the research? What support can still receive, and how does collaboration look like? So yeah, Dr. Brianna, you can start with that.
Sure. I think independent research looks different depending on what stage of your career you're at. I remember being 18 and going into physics and thinking, oh my goodness, am I going to have to come up with my own new idea just right now off the gate? Because that's a little intimidating, thinking about what you can do and what new idea you can add to physics. But I think the cool thing about research is it just builds, and you just do the next door and the next door and the next door. And when you're an undergraduate, you get a bit more help, of course, than a PhD student would get, and then as a postdoc, and then finally you're kind of in the realm of more independent research after that process. And just to kind of clarify those different stages, just in case we have some younger undergrads. You get your undergraduate degree, and then about half of physicists go and get their PhD. And then after your PhD, you often do a postdoc, 1 or 2 postdocs for 2 or 3 years, I think. And then you can go into a career in national lab or be faculty in academia. And each one of those stages, you're kind of you need less help. And so I think when you're an undergrad, independent research looks like your professor or mentor will give you a project, and you'll go do that, and you'll do it independently, but you can also come back to them with questions. And then as a graduate student, you might have less and less questions, as a postdoc less, and then you're finally into a bit more independent research as you get further in your career.
Yeah. It looks wonderful, but it is not that easy thing. I think the research is one of the toughest thing to do. So, Dr. Anupma, if you could share some insights on this.
Yeah, sure. So as rightly said by Dr. Mount, for me also, like in the pursuit of scientific knowledge, what I feel is independence can be a guiding star. So that's one perspective. And with that, like insight, the direction that I think, like when you talk about independence and research, then basically you're talking about more degree of significant efforts that you will be doing, or you'll be taking help from others for guiding your research direction, starting from its designing, methodology, its outcomes. So with all those perspectives, yes, doing independent research is, I would say, it's an opportunity. And if you take like support, but still we have to rely on some supports, like funding is one. Second is more collaborative efforts that you do in independent research. Also, hails to the success of the project. The other thing is more like institutional resources that you have to benefit from while you're doing an independent research. That is also important. And team efforts. So while you're doing independent research, it's not like you're master of one thing, right? So probably for the success of the whole project, you might have a good team that will contribute to the success. So doing independent research, I would say, is an opportunity. And to reach to the completion is the expertise, experience that push it forward. So that's what I believe. And I look forward to the perspectives from other panelists.
Yeah, Jesus, we would like to have your thought, please.
Yeah. So I think maybe speaking as a current PhD candidate, I just proposed my thesis. So I think on this research project, I'm the one that's leading the charge. I did have help from my advisors kind of formulate the idea, but I think I was very fortunate that they allowed me to, for about a year, kind of read the literature, try out a couple things in the experiment, to just kind of build intuition for the science and also see if there was anything that I wanted to pursue further. But I am in charge of kind of the direction of the project, the milestones along the way, and the timeline towards accomplishing it all. But of course, as mentioned by the two panelists, there is plenty of help that I get from other staff and engineers and scientists here in my lab. For instance, there's a lot of electrical engineering in my project that I'm definitely not the expert there. So working on a maybe weekly, monthly basis with our local electrical engineer is very helpful. And yeah, that's where I'm able to be now. But as an undergraduate, I was also in a position where it was very daunting and scary to think of, like, wow, I have to contribute a piece to the already big field of physics. But that's something that slowly went away as I moved from undergrad to summer research experiences now.
Yeah, that's great. And as an undergraduate, I'm also feeling the same as you mentioned about the fear of in entering the research field, and the fear of the syllabus, because physics is a very giant subject, I think. So it's not that easy to cover up all the stuff. So yeah, moving ahead. So tell me more about your collaboration. How does the collaboration look like? Dr. Anupma, you can
Okay.
start with that.
Yeah. So for me, collaboration looks like a complete circle. Like when we start from one lab, like as I mentioned, like we can be trained for one discipline with minor in other subjects. But with that expertise, when we talk about collaboration, then basically we are sharing more inclusive and diverse environment. So we're talking about including others in the research perspective and taking their help based on their expertise. So for me, collaboration plays an important role, whether you are in academic or industry, because research cannot be confined to one lab. So when we talk about propagating it globally, then collaborative efforts are basically pioneering efforts that we need for the success of the research project, making it from more towards lab to market development. That's what I feel, and I would like to hear from others.
Yeah, Dr. Brianna, you can go on that.
Oh, yeah, collaboration is incredibly important. So I'm on the LZ direct dark matter detection collaboration, and that's about 200 physicists. And so when you're building a detector with so many people and then running the detector with so many people, everybody has their little piece. And then, so you do your little piece at your home institution, and then you have meetings and you chat with it, and people ask you questions and they say, have you tried this? Have you tried that? And then that gives you great ideas and you go try that. So you're never truly working independently on some of these big collaborations, because you're always receiving inputs from colleagues and then you give them inputs, and yeah, there's a lot of collaboration. I think I probably have 4 or 5 meetings with folks from LZ around the country each week.
Okay, that's great. Jesus, we wanna if you could have more, you could share more about your laboratory collaborating experience with engineers, as you mentioned. You mentioned about your experience collaboration. Yeah.
So as two panelists have mentioned, like it's almost impossible to escape collaboration. It's very important and very vital to making progress. And actually, my PhD thesis is a collaboration with another national lab. And so it's gone from my advisor being an expert in, say, like solar physics, and me doing my thesis on magnetospheric physics, and our collaborator at Los Alamos also doing similar magnetospheric physics and a bit broader heliophysics. So I think meeting weekly and chatting and formulating my project, it was very insightful to get knowledge from experts in slightly different fields, helping me put together my ideas. And so it's very beneficial because I get to hear from different sides of it. And I think that's what helped formulate a good thesis project for me.
Yeah. So yeah, we all have, we will always have this experience to learn from our peers, and hope our audience and we as an undergraduate students will understand the importance of collaborating with others and having those necessary skills. So yeah, moving ahead with the next question. Now, we would like to hear from you. What are the most necessary tools that a student should master before starting their research as an undergraduate? So yeah, Jesus, you can start with that.
Yeah, I would say being very attention to detail. So just because you're poking at things in science, trying to make new discoveries, there's a lot of things that you have to be able to reproduce and fully understand. And so when you do trying to investigate something systematically, having the best recording of it all, it will go a long way. And I mentioned this just because I'm kind of going through this with my current undergraduate student that I'm mentoring. It's taking me as an undergrad and was learning, and how was just filled with questions, and a lot of the times I've answered it previously and it was in my lab notebook. So funny enough, but I think being very attention to detail oriented goes a long way in research.
Yeah, and we should learn from our mistakes. We always make mistakes, and early in the career, I think it's we are more vulnerable to making mistakes. So yeah, Dr. Brianna, we would like to hear from you on this.
Yeah, I think as an undergrad entering the field, I definitely agree with thesis, and I think curiosity is really important. Like having a mind that wants to know how things work. So, because I think sometimes physics is like, oh, I wonder how that works, and then that leads to something else, and I wonder how that works, and this and this and this, and following those leads down and tracking them down, and to be honest, I think hard work is important. Having a good work ethic. And that's kind of the start. That's the foundation of what you need. And then as you progress, there's other skills that are very good to have depending on which area of physics that you enter. I'm seeing I run an RU site in the summer. So that's a 10-week summer research program for undergraduates. And I'm seeing a lot of folks with more computer backgrounds. So a lot of double majors in computer science. We used to see a lot of double majors with physics and math, and now it's physics and computer science, I think. And I don't think a major is necessary, but I think having a background in something like Python is really great for any field of physics. And then if you're going to be an experimentalist, getting your hands on things in labs is important, just volunteering for a professor to help them fill their nitrogen once a week, or help them do some piping, or do some wiring or something like that. Just getting any kind of hands-on experience. But I don't think people are expecting that sort of thing from an undergraduate. So I think the biggest thing is having that curiosity, attention to detail, work ethic, and then just getting in the research and learning as you go.
Yeah, I think learning in the lab is very important. I remember when I was not able to handle a simple vernier caliper. So, Dr. Anupma, you can go.
Sure. So I agree with the other panelists, and mostly the thoughts shared by them are coherent with what I would like to say. But adding to them, like as they mentioned, like as an undergraduate researcher joining a lab, so definitely working hard. Their passion is more important. That's another thing I want to add. Passion for research, and as mentioned by Dr. Mount, curiosity is another important aspect that an undergraduate researcher should have before he or she, would like to pursue research. That's one thing. The other tools which I would recommend, like for any undergraduate student when they are starting their research, and the mentors who can help them with, is mainly understanding the research fundamentals. So they can, share with them tools like Google Scholar, which can help them to stay updated with the progress going in research. And they can have their library set based on their research objectives. The other thing would be talking about critical thinking about research project. They can help them, and the tool can help them. The other thing would be the database management, how they are progressively collecting data and managing it for presenting it to their mentors, talking about that, and have more good hands-on. And apart from that would be the lab learning experience, as Dr. Mount already mentioned. So these are like small tools and experiences that can help undergraduate researchers to progress in their careers.
Yeah, that's really great. That's really great. And I hope we all can learn from this. So yeah, moving ahead in our conversation. And now we would like you all to address a problem which as an undergraduate we face, that how attainable is undergraduate research while taking classes. We always have some kind of issue with that. So yeah, Jesus, you can share your experience.
Yeah, so I remember from undergrad it being kind of like nonstop go. I signed up for maybe a full hand of classes, and I remember being fortunate to have an advisor that was understanding of that, but at the same time, I was very eager and hungry to do the research. So you would always find me in the lab late at night on a Friday, maybe a little bit on the weekend, and it was more like during the week I would maybe work a couple hours in the middle of the day, maybe revisit the lab at night, but it was definitely something no more than like 20 hours, I think, while trying to handle my classes. It's quite the balance, and I think there's pockets of time where you'll be able to be in the lab maybe the full 20 hours a week, and maybe the next week you can only be in there like 2 or 5. And I think that so long that you're putting in the hard work and keep focused, having those kind of ups and downs of times in the lab, it's not necessarily a bad thing as an undergraduate. That's just kind of the way it's going to go. And yeah, can't forget that you, in order to keep making progress long term on your research, you have to maintain good grades in your classes.
So yeah, it's not it's not easy to maintain both the things together. But yeah, as a student, we have to do that, and we have to face all these kind of things. So, Dr. Brianna, I would like to have your thoughts on this.
I definitely agree with Jesus. I think research during the semester can be a bit rough because your focus should be on your classes because they're the foundation for everything else. And I think his time that he gave was about right. I have some students that work with me 5 hours a week, and that's what they can do, and some that do 15. That's kind of the range that I usually see from my students. However, I do want to put a plug in for summer programs. And so that's academic research at your home. That's research at your home institution during the semester, but there's also summer research opportunities. And so there's these NSF RUs that many institutions around the country host a site, 10 weeks of summer research for international students. Several of those sites, so you cannot technically be in an NSF RU as an international student, but several of those sites also host undergraduate programs along with their NSF site. So you could contact them separately. When I'm done talking, I'll put some links in the chat. So that's the NSF-RU program. And then there's the DOE SULI program, which is National Labs. And the nice thing about the SULI programs is that you just have to apply once. And then you cover most of the DOE National Labs, I think. So the summer is very nice because your complete focus is on research. NASA also has internships, and National Labs also have internships outside of SULIs. So there's opportunities for summer research, and I would encourage folks to get as many research experiences as possible in as many diverse fields as possible. Work in biophysics with a group of a couple folks. Work with me for a summer underground with these big collaborations, and kind of see what you're interested in, what you're not interested in, maybe, and really try to maximize your summers. And by the way, both the RU and SULI programs are paid. You get a stipend each week, and they also pay for your room and board, and they pay for travel to the site. And so you can still make money over the summer doing these research opportunities.
Yeah, okay. That's wonderful to hear from you. Dr. Anupma, please share your experience.
Yeah, sure. So yes, as rightly pointed, like undergraduate research is attainable at universities, offering vast spectrum of opportunities. That's one aspect. So as Professor Mount mentioned about REU, NSF REU, and other schemes. So similarly, our university at Purdue also has undergraduate research opportunity programs, which offer funding support like 8 hours in a week for undergraduate. And that is one kind of opportunity that helps them to grow as an undergraduate researcher, and also other opportunities led by lab like PIs basically that offer research assistantships like undergraduate research assistant for a project. So all those opportunities push the undergraduate research forward. And I must say, like, all these funding opportunities help undergraduate researchers to stay motivated and also more responsible for the project that they are working on. So they are very helpful. That's what I wanted to highlight.
Yeah, that was wonderful to have these experiences from you all, and I hope help us too in starting our first research or maybe during our research. So next, we would like to go ahead and our next question for having your more experience for learning from you guys. So next question is, how would you compare the independent that the independence that undergraduates, PhD students, postdocs, etc. have in research lab? How do you compare that independence? So yeah, Dr. Anupama, you can start with that.
Sure. So as I mentioned, like to me, independence would be a guiding star. So with that perspective, independence at different levels, like as an undergraduate, a doctoral student, or a postdoctoral, may vary based on their experience, expertise, and also the type of research project they are handling. So to me, as an undergraduate researcher, mainly you are mentored significantly by your mentor supervisors that help you to grow in that career. And also in the beginning, I suggest I think like undergraduate researchers are more dependent on mentors, but over experience, over more relevant inputs in the project, at the later stage, they might even excel and become expertise in the project that they are handling. So that's one thing, like more of experience help you to grow as an independent career. Similarly, for PhD students, I feel the degree of independence is more, because they are basically stating their research, starting from the research designing, the contributions that they are making. Although they are being also supervised with their mentors, they're having a major part to guide their research. So that varies. And for a postdoctoral researcher, again, it is highest level of, I would say, independence, because they are basically majoring in their expertise area, and then they design their projects and have a good guiding star for the project. So that's what I feel. Like it varies from the level, and it is more acquired based on the experiences and expertise that we get over time in the field. So that's what I would like to share.
Yeah, no, that's great. That's great to have you, to hear from you. Jesus, if you would like to have insight on this.
Yeah, I think the independent aspect of my undergraduate research experience was doing some of the work, like physically in the lab, because, barely getting into the field, getting into a project as an undergraduate, it was maybe a little bit more of, instead of my advisor and I discussing thing, it was more like my advisor, telling me the results or telling me the conclusions, and a little bit more about, me doing some of the work in the lab and slowly working towards, understanding it and being an expert in it. I remember at first taking measurements, doing things in the lab, looking at the data, plotting it, and kind of more like taking it to my advisor to see what the results kind of said. But now that's the complete opposite. Now, as a PhD student and being in charge of my thesis, I'm doing all the work in the lab, and I look at the data and I analyze it, and I don't really take it to him until I have sensible or something to discuss, or more like tell him. It gets to the point where you're very much the expert on your subject, and when you're showing your results, talking about them, you're presenting them in a way that you kind of know what's going on, or you're defending or proposing what you think the results are. And I think that's the independent part of it now in the PhD stage.
Okay, that's wonderful. And Dr. Brianna, yeah, you can share us with your experience.
Yeah, I think what the other two panelists have said are excellent. I don't know that I necessarily have anything to add, to be honest. I think it's just I think of it as being broken into smaller pieces for an undergrad. So your advisor might break something down into a very small piece and please go do this and try it. And if you have any problems, let me know. Whereas a grad student might get a bigger chunk and then at the end of your grad career and into your postdoc, then you're coming up with the problems and this is what we should do next instead of your professor telling you what you should do next. So that's, yeah, but I think the guidance just kind of is a lot as an undergrad and then hitters off at the end when you're getting closer to being a postdoc.
Okay, so I think it really will help us as well, and we will, when we have our first research project done as an undergraduate, and then we'll go for masters and doctors and so on. So yeah, now moving ahead in our session. So you have shared about your experience in attainability of undergraduate research during the classes or while taking the classes. So we wanna ask from you more about it. A follow-up question that how are these answers different when thinking about theoretical research rather than experimentational or computational research? So, Dr. Anupma, you can go on that.
Sure. So as far as like my experience so far as an experimentalist, what I observe, like for a theoretical like person who is working in theoretical research, basically the level of independence, the research design, and there's more flexibility basically in all these aspects for a theoretical researcher. That's what I observe. And when you talk about more experimental research design, then you need to have more of hands-on experience in lab research activities. So that's something is a different as compared to theoretical research. And more with when you talk about theoretical research designing, then definitely you have more independence in creating your own design models. And then with the help of your advisor, you can, test them and observe the objectivity towards their research. So yeah, but I would like to hear more from the other panelists in this regard.
Jesus, you can share your thoughts on that.
Yeah, this one would be a little hard for me because I don't know if I've had any or much theoretical and computational research. I'm just trying to think like my collaborators or some of the students that I know here. I think it does come perhaps with maybe a little bit more flexibility. Some of my classmates or lab mates that do computational research, their aspect I think sometimes can move a little bit faster, just because of the more day-to-day and ease of access to changing variables or changing the experiment. I think they have a little bit more independence in that way, at least from what I've seen, in the amount that they feel they need to meet with their advisor or collaborators. But yeah, but unfortunately, personally, I don't think I can speak much more to it than that.
Yeah, that's really fine. And Dr. Brianna, we would like to hear from you on this.
Yeah, I think unfortunately you have 3 experimentalists up here. And so I echo what they say, and I've never been involved in theory research. But I do have a good friend who is, and it's my impression that she often takes older students that have had some more classes as an undergraduate, whereas I can take you underground. I'm taking a student underground this afternoon and show you around and have you do things that start the learning process process with experimental work before you've necessarily had some of those junior level physics classes. Whereas I think theory, you have to have more of a foundation with your classwork before you start research. That's just my impression. And I also think I very much echo that I think you have a bit more freedom as an experimentalist. I write a proposal to the NSF or DOE and I say, I'm going to do this, I'm going to build this thing or research this thing or something. And so my funding is very much dependent on whether I complete that. Where I think theorist funding is a little bit more flexible on what they can do with their research. So I kind of think it's tied to funding, to be honest. But yeah, those are just my impressions.
Yeah, okay. That's really wonderful to hear. So we are done here with the questions, and we just have a time problem. We always have a time issue in our webinar. So Keshav, I think it would be great if it it is the great time to go for the Q&A session, Keshav.
Yeah, sure.
Yeah. So as mentioned before, we have this Q&A panel here in the chat box, and we will be taking questions from the Q&A session, and the speakers would like to give their answers on this. So now we have our first question from Bhaskar Singh Rawat. How a graduate student with research idea can do independent research without an advisor? So Bhaskar has not mentioned the speaker for the particular question. So you can go, any one of you can go with that.
I would be interested in seeing what the others think about this question. But I can take a stab at it. Usually when you're in grad school, to continue in grad school, you have to have an advisor and a committee, because all these grad schools want to make sure you graduate. And so I'm not sure that you'd be allowed to continue in graduate school, in particular pursuing your PhD. Now, this might be different if you want to end with a master's. But if you're pursuing a PhD to be admitted into candidacy, where I went to graduate school, you had to have an advisor and a committee, and you had to present a prospectus. This is what I plan to do. It sounds like Jesus might have just finished his. But I don't know that it's possible to pursue graduate school. Might be possible to pursue research, but I don't know that a graduate school would let you continue without a committee or an advisor. Very interested to hear what the others think.
Yeah, I agree with Dr. Mount. Like, definitely you need a advisor and also the committee to help you with guiding your research project. So that's very important and a major requirement at every university. However, like what I feel like you mentioned, like the graduate student with more research idea can do an independent research, but not without an advisor. So that's advisor is mandatory. However, you can still pursue an independent research, taking the significant role in conducting your research, but also discussing each and every fact with your advisor and taking their advice in propagating your research. So that's important, what I feel.
Yeah, I think that's absolutely right and spot on. That yeah, there's no way to do graduate school without that. But I maybe I'll take this question as what to do if you didn't get into grad school your first attempt or waiting to reapply, because I did have a friend from undergraduate go through that experience. They applied their first year, didn't get in, and wanted to stay active leading up to it. And what they ended up doing, since it'll almost be impossible to do research experimentally if you're not tied to an advisor, a group, or an institution. They did independent quantum mechanics simulations. finishing their undergraduate experience, they kind of knew a little bit of quantum research, so they kind of had a little help in the what to ask direction. And so they were able to continue that for a year until they were able to reapply to grad school the next one. But yeah, that's assuming maybe that's the way that question was asked.
I might add something too. Oh, sorry.
Yeah. Dr. Brianna, you can.
Often in US graduate schools, your funding for graduate school after the first year or two is through your professor's grants that they have written to do research. That's not always true. If you have a fellowship or it sounds like with my UK colleagues, the government funds their graduate school. So the professor doesn't necessarily have to come up with funds to fund a graduate student. But if you have your own funding for graduate school, I would suppose that if you approached advisors, they might be willing to let you explore that research as well. So just another little tidbit.
So yeah, I think Bhaskar has got his answer. Well, now next question is for Dr. Mount, and this is from Syed Jahir, if I am correct in pronouncing his name. For Dr. Mount, you mentioned physics with either math or computer science. Is it one or the other? Can it be a combination of both? That's his or her question.
Yeah, so what I was referring to was majoring in physics and math. So often physics students will double major in math because to do physics, you're already about halfway to a math degree anyway. So adding on upper division math classes sometimes makes sense for physics students. But with so much computational physics happening, we're seeing people double majoring in physics and computer science. And I think that adds quite a bit more classes than the kind of classical physics and math double major combination. But I think it is being useful for students. So yeah, I was just talking about double majoring. Completely fine to just get a physics degree, of course. A lot of students do that. It's not definitely, I don't want to imply that it's mandatory or anything like that to get a double major. Just students often do double major in math just because it's kind of a natural fit as far as classes go. And it can be useful in graduate school. But definitely not mandatory to double major. And even if you don't double major, you can do things like minor in computer science to get some more classes under your belt before grad school.
Ritik, mic.
Okay, I'm really sorry. I was not aware of that. So our next question is from an anonymous attendee. He or she want to ask, I want to ask how an early career scientist or graduated individuals can do independent research without joining any research institute. So you can answer it one by one.
This is a tough one. I don't know if the other panelists have any ideas. I hate to say it, but it's all about funding. So if you don't join an institute, it's hard to convince folks to give you funding to do your research unless you're independently wealthy or something like that. I don't know if other folks have ideas on what that would look like.
Yeah, I agree. Like, definitely when you're early career scientist or graduated individual and you want to pursue an independent research, you need to have an affiliation, a place where you want to conduct your research. And definitely when you want to conduct your research at a research institute, you need funding source to drive the research. But definitely, if you want to, you can also enroll yourself as a startup, or the other mode is to pursue whatever you want to do as an independent research. But still, you need to have funding to progress the research. That's what I want to add. Maybe other panelists can add more.
No, I think that's it. I think if you're not going to grad school or joining an institution to do research, I think it's either that or you have enough money to start a startup. So I think those are your only options, unfortunately.
And I'm just going to jump in just because we've been talking a lot about academia and going into graduate school. So I just want to make it really clear that in the U.S., I think APS always does these studies, and it turns out that about half of students graduating with undergraduate degrees in physics go into academia, go into grad school, but half go into different industries. And so you can certainly get a research job right out of your undergraduate degree in industry or at a national lab as a research tech or something like that. You don't have to pursue your PhD. Or you could do other diverse things like science journalism or patent law. There's all sorts of things that you can pursue. But since we're talking about research, the kind of two paths are you could become a research tech right after school, right after your undergraduate, or kind of pursue the academic route with your PhD. And it's about half and half for undergraduate students in the US.
So yeah, we have the answer of the anonymous attendee. So yeah, next question. Moving ahead with the next question from Muhammad Abbas. So as a beginner, there are many expectations and fears. The fears lead to the stress and the anxieties. How to handle these problems during the downtime? So anyone can start with that. Dr. Anupma, you want to add something?
Yeah, sure. So definitely when we, as a beginner, we face many failures, and we also we sometimes also feel much overwhelmed with the, lab's progress, other students or other community progressing faster than you. So definitely we have fears to lead to stress and anxieties. So in that regard, what I would like to highlight is we need to be talking more about mental health awareness that we should all do in order to face certain situations. So that's something we want to highlight, and we want to discuss with our peers to reduce the stress and anxieties. And as I want to also mention, like you want to stay more motivated with all the looking into the good side of the research, like the contribution that you make into research will definitely help to build a good ecosystem further. So that's something we want to have our passion, fulfilling us, and want to stay as much as far from stress and anxiety. So for that, we need to have mental health balance.
Yeah, I think it's very important to focus on your mental health aspect of it. I think if you're doing research, it's good. You may have those fears of, or at least starting up. If I don't do the work good, or if I don't do the work fast, then I'm going to be deemed not worthy of my position in this lab, and and you start thinking, well, then maybe this isn't for me. But as an undergraduate, and assuming you're in a healthy lab, you should not be being pushed to the point where you feel these ways. And if you're self-inducing these feelings, then it's important to know that to slow down. And you're an undergraduate, you need to build the foundations. So that means your classes come first, and slow and steady on your research will still go a long way.
Yeah, I definitely agree with both of the panelists. And I think something else that, so we've all had fears and anxiety, all three of us up here, it sounds like. And it's completely normal. And you'd be the oddball if you weren't a little anxious every so often. So it's extremely normal. And I think you'll see that it's extremely normal if you join your local Society of Physics students or attend conferences and talk to other undergraduates and graduate students. So I think finding sense of community can be really important, chatting with your other students, with your peers. And I think having outside interests is important. So not making physics your entire life. Have some hobbies. I think exercise is important. And I'm not talking exercise like go run a marathon or something. I'm just talking about go walk and get a coffee, go walk outside and enjoy the fall leaves for 15 minutes even. Getting up and out, and having outside interests and outside hobbies where you have friends who aren't physicists, and which is a bit hard, to be honest, in grad school and things like that, but try. I think it's important to like, I think Dr. Thakur said, have outside, to have a work-life balance.
Yeah, so it's a great experience to join the physics community, the local physics community. It will your peers or your classmates or you know your fellows really help you to go through your down and ups. So our next question is from Michael, and he is asking if we have findings in our independent research project that we want to share, what is the process of publishing like? So yeah, anyone can go on that.
I have not published anything yet, so I can't answer this one.
Yeah. Dr. Mount, do you have some insights in this?
Yeah, I think this question coming from an undergraduate, I think that's wonderful, by the way. And it really depends on the scope of what your research was. And so disseminating results can be done in a lot of different ways. Usually the first step is a poster at an APS meeting often. And then a talk perhaps at a conference. And then if you're truly looking into publication, I would encourage you to work with a faculty member to do that process. Just generally to let you know what the process looks like is you come up with a paper that you write yourself. You hopefully get as many eyeballs on it as you can at your institution, perhaps, and maybe some colleagues in related fields. And then you submit it to a journal. APS, of course, has lots of lovely journals that we all love submitting to. And they will take it and they will send it to a review panel, usually of 3 people or so. And those reviewers will send you the reviews. If it's deemed that those changes they want to make are small, then you don't have to go through a second round. You can make the changes and send it back to the editor. If they have found bigger things that you need to go address, then you go address them, and you write responses to your reviewers, and then the editor accepts it or not. It may or may not go through a second review round, and then you polish it up and it's published. But different journals have different methods, and of course the gold standard is a peer-reviewed journal. So I think it's very important to publish in peer-reviewed journal. And then of course there's archive that anybody can submit anything to. But again, I would encourage you to work with a faculty member on the next steps.
Dr. Anupma, do you want to add on this?
Yeah, I agree with Dr. Mount that, and I would encourage the audience to work with the faculty or your peers to understand how these research findings that you may have on your independent research project can be published and also presented at different levels like conferences, meetings, to showcase your research findings. So I echo with Dr. Mount.
Yeah, okay. Now, Keshav, I want to hear from you that how much time we have left in the Q&A session, because we have
we have
some
10 more
questions
minutes.
are still.
I will let you know. We have still have time to take few more questions.
That's fine. Yeah. Our next question is, from an attendee for Mr. Perez. I know it has been discussed that joining programs such as NSFRU and DOE SUI help expand network. Are there any other recommendations for finding other researchers with similar interest if what particular specialty is not offered at one's institution?
Yeah, so yeah, getting undergraduate research experience at other institutions, whether it be a university or a national lab, is very important and something that I think was crucial to my undergraduate experience. And at my home institution, there wasn't any plasma physics, so I definitely had to go searching. And while something like the SUI program is very great for plasma physics, another thing I did was look through plasma research papers, track down the authors, and see what their home institution was, and then kind of visit those university websites directly to see if they themselves offered and research experience for undergraduates in the summer. So it was a lot of a lot of tracking specific professors and universities down, but at the end it was well worth it because I was able to find not only opportunities, but for the immediate undergraduate research experience, but I ended up applying to a lot of those schools for graduate school once I graduated because I figured out that they had a program for me. So yeah, I think if you are absolutely lost in the water with where to find the research, if you can at least find a research paper on the subject, try to track down those authors or those institutes.
Yeah. So moving ahead to the next question is from Tulika. Hello, I wanted to ask about how to set benchmarks in experimental research. At the moment, as an undergraduate, my PI doesn't expect much other than just learning from the lab. However, I want to know what approach I should take to set my own benchmark to show results. Yeah. So, any one of you would like to address? Move ahead.
Sorry. I think that shows tremendous motivation, and it's wonderful that you're thinking about that and wanting to do more and more. If you see a benchmark, set it and try to meet it. And I think that would be a very impressive thing for a faculty member to see.
Yeah, definitely. I agree with Dr. Mount. That's a great motivation for an undergraduate research. And what benchmarks that I would suggest would be like show your volunteerism for ongoing research activities, participate actively, understand the and critically analyze the aspects of the ongoing research. If you have any results, then contribute to understanding more. And by this way, definitely you'll be able to present more of your research interest in the ongoing research study. And that would help your advisor to understand like how curious you are, and he might or she might help you with more direction to your research. That's something I would like to add.
So, yeah, and I think now I should move on. So, next question is from Basil. I'm not sure if I'm correct pronouncing his or her name correctly. So, question is, I have a mentor and I work in his lab, but there is no
I can maybe jump in and read that, since I think we're having some internet issues.
I can read the query for you. I
Yeah.
have a mentor and
Sorry
I can
for-
work in his lab, but there is no someone else with same experience. And because of this, I can't try different field. Do you think this is healthy for a research candidate? What can I do about this? Brian, you go first, then Anupama, and then he says.
Okay. I'm not sure I have a great answer for this, because I'm not sure I understand. So I have a mentor and I can work in this lab, but there's not someone else with the same experience. So it sounds like you might be at a small institution with just one research field in physics. And I think a lot of I think, like we have talked about, you can pursue these other opportunities at other institutions for research in the summer in particular. But I would also say that undergraduate research in the topic that you pursue later is not required. and a lot of research is of course transferable among fields. So for example, I had a wonderful experience at Florida State with my advisor in atomic physics. But now I'm doing nuclear and particle physics. But I think a lot of skills are transferable. I can pipe with Swagelak. I can run LabVIEW. I can a lot of work in a team, learn how to write posters and things. A lot of those skills are very, very transferable among the fields. And so it would be good to get experience in a different field, because then you'd see if you like it or not. But I don't think it's necessary. And the other thing I will say about PhD programs is often at these larger PhD schools like Florida State, where I went, your first year is spent listening to seminars from different groups doing research at that institution. So I think it was really terrible. I think it was every Friday afternoon at like 4 or something that we had to sit at these seminars for nuclear experimental, nuclear theory, condensed matter theory. So we got exposed to a lot of the different physics at that institution. And I think it's also not necessarily uncommon for someone to start in a research group as a PhD student, realize, oh, maybe this might have been a little misstep. Maybe this isn't the field for me, and choose another professor just because they realized the field wasn't quite for them. But I'd be interested to hear from others.
Yes, I agree with Dr. Mount that whatever experience that you get with your research project definitely is transferable when you pursue higher education or you want to switch fields. So that's something, it stays with you and it helps you to pursue different fields if you wanted to. And the other thing I would suggest is identify the different fields that you want to pursue, and you can look for opportunities to get enrolled in those research activities. So yeah, that's what I just wanted to add.
Yeah, I agree with both panelists. I think it's great if you're able to try out a different lab or even different area of study, but by no means truly limiting to just end up in a situation where you can't try something out at your home institution. And like they said, that's what summer research opportunities are for. And I'll mention that I think 80% of my undergraduate research was condensed matter physics, but it was in a quick, seamless, and easy transition to move over to plasma physics once I was in graduate school. So that should hopefully not be any big limitation.
Okay, this one is the last query for the sake of time. So last question is from Kurat. His question is, can and should we shift the field of research from experimental work to theoretical after graduation? That is PhD or master's. What is your advice? Should first learn the theoretical tools and then join any research institute for future work? Which tool you suggest as important to learn, and to what extent? So Anupma, then Brianna, and then Jesus.
Sure. Thank you. And this is a great question. And often while doing research, we come to know, like, definitely, like, probably the theoretical research is more beneficial for you, rather you're doing experimental work. So yes, the shift is possible. And to have that shift, what I would suggest is you need to be passionate about and steady about that shift, because that might be challenging as well, because you're an experimentalist and now you're planning to move to the other field, which is a theoretical or computational. So it is possible, but you have to stay steady and you have to stay motivated to understand, like, from the scratch. Basically, you're going to start from the scratch and learn the theoretical tools. And also, it is possible to join research institutes when you want to switch from experimental to research, like theoretical designing. But tools, I'm not really sure, because that's not my expertise area. But I would like to hear from the other panelists if they would like to add more to the tools and other aspects.
Yeah, I definitely agree with Dr. Thakur. So if you're switching from experimental work to theoretical or computation after your PhD, what that likely means is that you're doing a postdoc in theoretical research, which means that you are working under a faculty advisor or an advisor at a national lab or something along those lines. So you should ask them. So if you see someone that you'd like to be a postdoc under, contact them and say, I did my PhD in experimental whatever, but I'm really interested in theory. What do you suggest doing? And I think they're the people. None of us are theorists, but they're the people that are going to be able to tell you what you need to do. Oh, you need to go do this. You need to learn this. There are a lot of summer institutes on theoretical physics. We have one here at Sanford Underground Research Facility. And that particular one is kind of neat because it's about a month long, and theorists come and go, and there's different topics each week. One week might be dark matter, one week might be neutrinos. But they also, a lot of experimentalists attend. And so there is overlap, and there are ways to shift. And I think post PhD might be the time to do it, because once you get too late in your career, then it's a bit harder to shift, perhaps, if you're trying to get tenure and things like that. But I think it's definitely doable, especially if you feel strongly about it, like Dr. Thakur said. And yeah, I would just contact whoever you'd want to work under, perhaps, and see what they suggest.
Yeah, I think those were great responses by about post PhD. I'll just add a little bit that during my thesis, I'm currently taking an active role in on some of the theoretical and simulation side of things. As I mentioned, my thesis project is a collaboration with a national lab, and the national lab is the side that is leading the simulations. But I did want an active role in it, so I kind of know what's happening behind the curtain on that side of the research. So I think if you're able to do that while still doing some of your experimental work, I think that can only be beneficiary.
Thank you for your great advice. So I believe we have to wrap this up. This is the all time we have today for the webinar. We hope we have covered most of the query, and apologize if we did not get to your question. We encourage you to follow up by sending an email to webinars@aps.org, and we will forward your questions to our speaker for comments. We would like to thank all our speakers, Dr. Brianna, Dr. Anupma, and Jesus for their time to participate in this webinar. I also like to take a moment to thank and acknowledge the effort of our Pulse team in making this webinar successful. These team members are undergraduate and graduate students, and they have put in a lot of work to make this webinar a success. Please change the slide. A recording of the video will be made available on the webinar homepage, to which you will be directed at the end of presentation. Please allow up to 5 days for upload. Lastly, in order to help APS continue to develop quality webinar presentation, please help us by taking a moment to complete the short survey as you exit the webinar today. This wrap up today's event. We hope you all join us again next time. American Physics Society, copyright 2023. All rights are reserved. Thank you, audience. Thank you, speaker. Thank you all. With this, we
Yes,
conclude.
thank you, everyone. Yeah, thank you, everyone. It's a pleasure
Bye.
talking to everyone.
Bye.
Yeah, thank you. Bye.
Stephanie.
Yes, awesome
Please.
job. Thank you so much.
Thank you. It was really helpful from your side, and thank you.
Yes, no, thank you. I think it went really well. The recording will be available. I'm sure Sarah will check it out, and I'm sure she'll be in touch with you guys about the next one.
Yeah.
Awesome.
Next is in November.
Yeah. You have a wonderful week, and hope to see you around soon.
So,
All right.
you too.
Yeah.
Same.
Take care. Mhm.